Hey guys, welcome back. It's your Comic Cosmonaut back at it again with another episode. So I've been out. I've been sick. I've been dealing with doctors and stuff like that. It's been 5 months. I'm so sorry, but I'll make this worth your time, alright? This is the episode everyone's been waiting for. And plus, you're happy to hear that I actually have an upload schedule going up. So you're not going to have to wait 5 months for another episode. Nah. It's going to be frequently. So anyway, I haven't decided how frequently it's going to be, but you won't have to wait 5 months. That's the important thing. But anywho, this is the Black Hole episode, the Black Hole series, alright? This is going to take me around 3 episodes to get to, so I was like, get through. So I was like, let's make it a series, Let's just do that. So, this is the Black Hole series. Let's jump right into it. I have some things that I would like to talk about in this first episode. This one's going to be the fun facts about black holes. It's not going to be, super deep. The next one will probably be super deep. I'm going to cover, one deep thing in here, but, not a lot, but, we'll get to it in the next episode, the deep stuff. But anyway, you can't see a black hole directly. I don't know if you guys knew that or not, but, with all the hype going on around black holes, especially since we got a picture of one, you guys can't see it directly, So, it's called a black hole because of its color, especially since light can't escape it. But what you can see is the effect the black hole has on the environment around it. So, if you're going through your little spaceship, through space, you're chilling, you're going about 35 miles per hour, and you're like, hey, what's up? What's that over there? There's a bit of space that's distorted. You would know that there's a black hole over there. And if it were close enough to a star, you would be able to see that star being shredded into the black hole. So you'd be like, oh crap, there's a black hole over there. I'm gonna take this exit instead of that one. Anyway, that's what's gonna happen, especially if you're in your little spaceship. That's what happens. So there are different types of black holes. There's primordial black holes, which are the smallest of black holes. They can range from an atom size to a mountain's mass. There's stellar black holes, which is the most common type of black hole, and they can be up to 20 times more massive than the sun. There are also a variety of these all over the Milky Way. And there are supermassive black holes, the largest of black holes being more than 1 million times the mass of our sun. Alright? That's cool. So, I got into a conversation, a discussion, if you will, on a Facebook post not too long ago, and they were talking about how they've created a black hole in a lab, blah 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 blah, and I was like, this is great. I want to see what people comment up here. And someone said, oh yeah, of course, let's create a black hole in a lab and let it suck us all in. And my little astrophysicist brain, my little wannabe astrophysicist brain cannot handle that joke. And I was like, black holes don't suck. You fall into them. They don't suck you in, you fall into them. Anywho, I came up there and I was like, I'll pull up the thread. I'll freaking pull up the thread and read it off to you guys. This is what happens when I'm allowed to have Facebook and allowed to have any sort of social media. As the black holes don't suck, they have an extremely high gravitational pull that pulls things toward it, but it doesn't suck things into it. This means you'd fall into a black hole, you aren't sucked in. Kind of how we stand on Earth and fall. You fall on your face towards the ground, but you aren't sucked down to the ground when you fall, you're just falling towards what's exerting the gravity. So if you were being pulled into a black hole, you would fall into it, because it's exerting gravity. And then they're like, can't you take a joke? And I'm like, absolutely not. I cannot do this. So people thought this comment thread was very interesting, so they started probing me with questions, and I absolutely loved it. I was having a ball. So this other person came up there and said, doesn't time freeze the closer you get to one? And I said, yes, to the observer, the person getting closer and closer to the black hole appears to freeze in time at the edge of the black hole. Notice I said to the observer, not to the person going in the black hole, but to the observer of the person going into the black hole, so the person standing behind and watching. So another nice person came up here and said, hey, why does this happen? I've never heard of this before. And me and a stranger actually went in on this together, and it was amazing because I never have any other person to talk about the theory of general relativity with. So they actually came up here and they were like, hey, the theory of general relativity explains this. I was like, yes, it does. And then another friend of mine hopped in there and was like, yeah, let's all explain it together. And we all started coming at each other with different comments about it. And here's how it went. So Albert Einstein's theory of general relativity, or E=mc², proved mathematically that traveling at the velocity of light, the passage of time actually freezes, and beyond that, time will actually regress, proving that not only does another dimension exist in addition to the first known three of height, width, and depth, but the fourth dimension of time itself, which is almost like a fluid construct if you think about it, which is weird. And then I came up there and I was like, yes, it's exactly right. And I was super excited about it because, like, you know, again, like, no one ever talks about these things, and no one ever talks about them in a way that is easy for others to understand. So I came up there with a little bit more simplified version of why time, you know, almost like stops and, like, you know, regresses. I said a few friends of mine, including the people up here, have talked about it, but it's best put like this, simply. Time slows down near a black hole due to the extremely strong gravitational field of the black hole itself. Einstein's theory of general relativity explains and states that this phenomenon is due to the extreme gravity of the black hole curving space-time in a way that affects all measurements of time and space around it and near the black hole, and matter around it too. So that means that it actually curves and messes with each dimension itself. So like height, width, depth, and time itself is another dimension, which is like the fourth dimension, which is great. Another cool thing to think about is wormholes. So here's the thing. The theory of general relativity actually does predict wormholes. So here's the thing. Black holes. People think that sometimes those can be wormholes because the theory of general relativity actually does predict that there are wormholes. But let's say that a black hole is a wormhole because it's a possibility. Here's how it happens. Is the black hole is so, the gravitational strength of it is so strong that it rips through space-time, basically, and it comes out to another portion of the universe, or somewhere different in space-time, so someplace different in space-time. So you were to fall into that black hole, you think your matter gets destroyed, right? Well, matter cannot be destroyed according to the law of conservation energy. The matter cannot be created nor destroyed, hence an atom cannot be destroyed. It can't be broken into smaller particles, and atoms mainly consist of three primary particles, which is an electron, proton, and neutron, right? You know, you always learn how many particles the atom was, you know, consists of, and that's an electron, proton, and neutron. Well, it can't be broken down into smaller particles. It just can't be. So that means that when you fall into a black hole, you are ripped apart, but you aren't destroyed. Your data is mainly just jumbled up and distributed somewhere else in the universe, which is an awesome theory to think about. That's an awesome thing to just have in your mind to think about. We actually have a black hole at the center of our galaxy. It's called Sagittarius A star, and it's 25,640 light years away from Earth. You might ask, how are black holes formed? Well, black holes are formed by the death of a massive star. The massive star, the core of it becomes unstable and collapses in on itself, right? And the star's outer layers are blown away. The crushing weight of constituent matter falling in from all sides compresses the dying star to a point of zero volume and infinite density called the singularity. So that's where a black hole forms. Well, I think that's it for this episode. I will get into a lot more in the next two coming up episodes, so stay tuned for that, and I'll see you guys later. So, bye-bye.